A very good evening to ladies and gentlemen. Am I audible, sir?
Yes, yes, very much.
Yeah. Very good evening, ladies and gentlemen. I, on behalf of the Society of Geoscientists and Allied Technologists, SGAT, convey my hearty welcome to our distinguished speaker and all the distinguished participants to this 8th episode of the Distinguished Lecture Series of the Society. Distinguished Lecture Series, which is also called DLS, is one of the flagship programs, bi-monthly program of the Society, which is primarily aimed at sensitizing all the professionals belonging to the disciplines of geology, geophysics, geochemistry, mining engineering, metallurgy, mineral engineering, environmental engineering, etc., by way of deliberations by the speakers, particularly distinguished speakers of national and international eminence. Friends, at this auspicious moment when this country is celebrating its 75th independence year, that is Azadi Ka Amrit Mahotsav, we have amazed us a very distinguished geophysicist of the country, Padma Shri Professor Dr. B.P. Dimri, who is going to talk and deliberate on a topic which is extremely pertinent in current times. And the title of the topic is Global Warming and Carbon Dioxide Sequestration in the Geological Formations in India. And with this, I now am privileged to invite our President, esteemed Professor Omkarnath Mohanty, to deliver his welcome address. Professor Mohanty, please.
Thank you. Good evening to everyone, and thank you, Sujit, for introducing Professor Dimri's lecture, actually, giving an overview of the topic. Friends, I only join Dr. Sri Sujit Mohanty and all our colleagues at SGAT in welcoming in our midst Professor Padma Shri, Professor Dr. B.P. Dimri, and many of our own colleagues of SGAT to this 8th lecture of the DLS. As a matter of fact, Professor Dimri, all the members who are present here, I'm quite sure that they are all looking forward eagerly to listening to you, and accepting you. Everybody else is perhaps a member of the SGAT. And ahead of time, I wanted to tell you that in due course of time, we shall also declare that whoever delivers the talk, becomes a member, de facto member. So that invitation will come later. And so all the people who are assembled here today, we feel privileged that the occasion is a very special occasion. 75 years of independence of a country is not a very ordinary thing, and particularly so for India. I say particularly so for India because India is sitting in the midst of a geopolitical kind of scenario where you will not find countries which have retained their republic nature continuously. And in spite of all the problems which we are actually facing in India, or some of them are perceived, we still are able to keep the image of India as a democratic republic, and that itself, in itself, to me, is a great thing. Secondly, we dedicate this talk by Professor Dimri. We are very privileged, Dr. Professor Dimri, that you have agreed to dedicate this talk as a talk which is on the occasion of the 75th Independence Day, or Swatantrata ke Amrit Mahotsav is what they say. This Amrit Mahotsav is very easy to say, but actually to continue the spirit of Amrit Mahotsav is not very easy. And the geoscientists and allied technologists, we have all assembled to listen to you as a part of this talk. Now, obviously, I'm not going to preempt what Professor Dimri is going to say. And what I'm feeling is that the topic he has chosen for us is a very special topic, and the carbon sequestration is again from various disciplines, is an area of great importance. Being a metallurgist, we are all conversant with what happens in the steel industry, in the aluminum industry, the metal industry in general, and the carbon dioxide, the role it plays, or the havoc it plays, and how they are captured and sequestrated and so on. So today we will be listening to a special talk by Professor Dimri on the same topic. I'm quite sure he will give a very, very different kind of perspective vis-a-vis the one which many of us may be carrying, at least I personally do carry. So with that, I join all my colleagues of SGAT in welcoming Professor Dr. Professor BP Dimri, Padma Shri in our midst, and welcome you. And we are sure that we are going to be treated to a great talk. Back to you, Sujit.
Thank you, sir. Thank you very much. Now it's my proud privilege to invite our senior member of the Executive Council, SGAT, Dr. Rajgopal Mohanty, to give the brief introduction of our distinguished guest of this evening.
Namaskar. Thank you, Mr. Sujit. It's a pleasant responsibility. Professor Padma Shri Professor Vijay Prasad Dimri, a well-renowned earth scientist of our country, equally known abroad, doesn't need any introduction exactly. But as a customary, I feel privileged and find pleasure in reading out a brief about him to the august audience of this evening. Professor Dimri, born in 1948 in Uttarakhand, had his postgraduate and PhD in geophysics from ISM IIT Dhanbad. His career started at the National Geophysical Institute, NGRI, Hyderabad in 1970, where he rose in ranks to become its director in 2001, a position he held till 2010. During his early career, he went to Norway in 1986 for postdoc and also for higher studies to University of Kiel in Germany and Norwegian Research Council, Oslo also. After superannuation in 2010, he became director of Gujarat Energy Research Management Institute, Gandhinagar, and also he was a distinguished scientist at CSR NGRI, Hyderabad till 2013. During 13 to 16, he became INSA senior scientist for 3 years. In 2016, he became Dr. Homi Bhabha Chair Professor at Central University, Hyderabad, till he was appointed President of the 36th International Geological Congress in 2017. Currently, he is Honorary Scientist at INSA at CSRA NGRI and President Federation Indian Geoscience Association. Among his publications, Professor Dimri has published nearly 135 research publications in referred journals. He has authored 2 books by Elsevier and edited 7 books published by Springer, Balkema, Taylor and France, and others. And also a monograph of American Geophysical Union. It is a great feat, sir. He has produced 9 PhDs. Of course, one of them is my co-alumnus and friend from IIT KGP, that is Dr. Parthapratim Mitra. I came to know today only. He is also attending this lecture. He is coming here among the crowd here and guided many postdoctoral researchers. He was project leader of many national and international projects and served many national international committees as its chairman and members. And among the awards, no less, list is very big. Professor Dimri was conferred with the 4th highest civilian award, Padma Shri, by Government of India in 2010. He delivered prestigious Sir Oxford Lecture in Oceania Geoscience Society, Bangalore, for the first time from India. Professor Dimri is first Asian to get Lawrence Lecture Award by American Geophysical Union in the field of nonlinear geophysics. Among many other important awards conferred on him include Professor D.P. Chatterjee Award by Indian Science Congress, Outstanding Scientist Award by FAP-CCI, Department of Ocean Development Award, National Mineral Award for National Geoscience Award by MOES, my Ministry of Earth Science, S&T Excellence Award, DST Uttarakhand, the Arshil Mishra Lifetime Achievement Award in 2019. And Professor Dimri has delivered Professor K. Naha Memorial Award Medal Lecture. He's my professor, sir. He was my professor. And in 2016, awarded by INSA, New Delhi. He is fellow of many learned academies and societies. Few among them are Third World Academy of Science, Indian National Science Academy, National Academy of Science, Andhra Pradesh Academy of Science, Founder Fellow, Telangana Academy of Science, Geological Society of India, and Honorary Life Fellow of Indian Society of Applied Geochemists. He was past president of Andhra Pradesh Academy of Science, Indian Geophysical Union too. We are really indeed delighted to have you, sir, amongst us this evening. Over to Mr. Sujit. Thank you, sir. Namaskar.
Thank you so much, Dr. Rajgopal Mohanty. Now, before I invite our distinguished guest for the deliberation, I have to make 3 requests. My first request to Mr. Trilochan Mahanta, our General Secretary, who will run PPT and will assist Professor Dimri during deliberation. Secondly, my request will be to Dr. B.M. Farooq, actually our very senior member of the Executive Council, who is going to moderate the question and answer session. And the third request will be to all the distinguished participants who will put their questions through chat box only, which will be taken up, the question and answer session will be taken up soon after the deliberation is over. Now it's my proud privilege to invite Professor Dimri to make the presentation. Professor Dimri, please.
Thank you very much to the society for inviting me to deliver a very prestigious lecture. It's an honor for me. And also thanks to the President, Secretary, and other members of the Executive Committee of the Society for just presenting myself in my CV. A lot of things has been told. I don't think I deserve all these things, but thank you, Rajgopal Mohanty Saab. Thank you very much for that. So today's topic, I have picked global warming and CO2 sequestration. The global warming is a problem. CO2 sequestration is the answer. It is a possible solution. The global warming is due to man-made, present day's global warming. Earlier, we had different geologically different stories, but today's global warming is man-made. And what is that man-made? It is some sort of, we call it the greenhouse gases. The greenhouse gases are, for example, carbon dioxide, NO2, and methane, and some few more are there, the greenhouse gases. But there are some positive forcing. These positive forcing, which promotes or which triggers for warming the Earth system. There are also some negative forcing. Negative forcing, for example, is what we call, we have the particles in the motion. I'm not from meteorology, but I have particles in the motion but it can reduce the global warming. And for that, they have some side effects. So we don't include those side effects, but we say some negative forcings also exist. But positive forcing are CO2 is one of them. And you can see after the revolution, man-made, our revolution, industrial revolution, the concentration of CO2 was started increasing. For example, if you see this first figure, this one, in 1935, it was just 310 or so. But today, it has become 419 ppm. So three years back, 404.16 ppm. So may I have the next slide, please? So I have planned the lecture as follows. I would like to say some important facts, CO2 and temperature. If CO2 goes up, temperature goes up. Environment and major effects. What are these effects, major effects for the mankind? And then solution, for example, CO2 sequestration, like we call it, and possible potential carbon dioxide traps geologically. One of them we call flood basalt, which is in our country. It's a Deccan trap. And then conclusions and way forward. May I have the next slide, please? This is the same slide I was trying to tell, that this is increasing and the temperature also is going up. So you see the next graph, how the temperature goes up. The next slide, please. This is the temperature goes up. So, for example, temperature at the rate of 5-year running mean or annual report, you can see it. The temperature, especially after 1970, when Industrial Revolution took place worldwide, that this has happened, the temperature started going up. As a matter of fact, as I was mentioning about the non-linear geophysics, I really belong to non-linear geophysics group. So where a system, if you do something in one part, it has effect on other part, what is called butterfly effect. The butterfly effect, suppose something is happening in some part of the world, say need not to be in India, it is happening in China, its effect will be in India also. And a small perturbation in Kenya, for example, in some small temperature rise, it will have effect in our Indian glaciers in the Himalayas. So may I have the next slide, please? So what is the share of the total emission of the carbon dioxide by the different countries? For example, the China is leading there 28.03. That is the 28 point is a very huge amount, followed by United States with 15.9, and then comes India 5.81, and then Russia is 4.79, and we stand third. But if all the European countries are united, because our population is in the very high side, if all the European countries are clubbed, that they will find the third is the European countries combined, and we stand at the fourth. So point is that whosoever does it, it doesn't mean that some country like Indonesia is 1.32, but anything they do, it has effect in the other part of the world. As I mentioned, it is a connected, interlinked, but through non-linear. A small perturbation rise. Suppose something is happening in some part of the world, forest fire, in Brazil forest fire, or forest fire do happen in our Uttarakhand, for example. It happens there. So it has an effect on the other countries. So it is not an individual problem. It is not some country's problem. It is a global problem. So we have to be careful. Yes, that's the idea of my talking today in this fest, today through this media, through this society. That is a global problem, and all of us has to be alert for that. May I have the next slide, please? Oh, different sources of carbon dioxide. So we can see that coal has 40% of the emission. What happened? Coal is the leading one, and then followed by oil and gas. But if oil and gas, you combine it, it becomes 53. The oil and gas 53 with the different oil is 34, gas is 19, and of course cement industry, that's 6%, and 1% is flaring and the oil burning. So the flares that comes from the oil fields, you can see it. So that is only 1%. But I'm trying to tell you here that oil and gas contributes CO2 as a 53%. Coal is also equally 40%. May I have the next slide? It's not today we have discussed this. It is 1912, August 14, say 90 years back. 90 years back, it was told that the furnaces of the world are now burning about this much of coal. It is in the newspaper, it came, so I picked up from there. Tons of coal a year with this burn, uniting the oxygen, combined with the oxygen, it adds this much ton of carbon dioxide to the atmosphere yearly. This was told in 90 years back, but we kept silent till 90 years. Now, Amit Mahotsav is there, as our president was telling about. So let us vote. India should vote. It's not that if we reduce it, we are loser, no doubt. Economically, there is some problem. But globally, it will be good for the future generation. It will be the wonderful things. Anyway, sir, we'll go ahead how it works. Next, sir. So what has been discussed by the climate modelers, the average air temperature near the Earth's surface increased around 0.6 degrees during the last 100 years and in 2005. Now it's 2022, but 0.6 degrees Celsius. And then climate model projections, again by the climate modelers, that the IPCC indicate that the average global surface temperature will likely, there is a forecast by them, there is a model prediction there by them, will rise from 1.1 to 6.4 degrees during the 21st century, which we are just now. So that is the minimum 1.5 and maximum it can go to 6.4. But you see the next slide, it says then if we make something, but there is a Paris Declaration, 1916, yet the Paris Agreement seeks to limit. All the countries thought we should not go, it should be below 2 degrees Celsius, arguing nations to pursue an even stricter target, 1.5. Even 2 degrees on the higher side, even they say it should not increase 1.5 at any cost. That is the thing that IPCC is asking for. To put this in perspective, the average global temperature has already risen 1 degree Celsius since the start of Industrial Revolution of 1970 onward. So only 0.5 degree, we can afford only 0.5 degree if we agree with the Paris Declaration, which India has rectified, of course. Next slide, please. This India rectified Paris Climate Agreement on the day of Mahatma Gandhi's birthday, 147th birthday, 3 years back. The countries, from the 61 countries, the total greenhouse gas emission is about 47.79. India is 62 countries to rectify the agreement, which should enter into force 1 month after 55 countries that account 55% of global emission rectify the agreement. So what was all countries are curious, they want to do it, but there are some problems. We'll see how other sides we can work on. If you want to CO2 emission, but there are some solutions, we are looking for solutions, because this industry, that development, that has to go side by side. That is a trade-off. With today's action up by India, which accounts 4.5% of the emission of the agreement, only needs slightly more than 3 percentage points to reach 55 threshold, as UN statement says. So that is the different countries are thinking in that direction. All are thinking, but work has to start. Next, sir. Environmental major effect. The increasing carbon dioxide emission is an alarming threat to the environmental pollution, potential cause for global warming that we have told in the beginning. So now I'll say, next slide, please. Major effects. All these points which I have noted can be told in 1 or 2 lectures each. But since we have some limited time here, the change in agricultural needs. With this, what is happening? The pattern, the precipitation is changing in different, within the, let us say, within India. So, for example, some places, for example, you say Rajasthan. Rajasthan never saw the rain monsoon for many years, but now there is a lot of water. If I, as lighter part, one 5-year-old boy, or maybe girl, when he or she woke up in the morning at 6, 7 o'clock, she came out from her house or his house, and then he saw some water on her head. Then he asked father or mother, parents, why are you throwing water on me? Because we are not throwing. Then she saw parents, they saw there is a drizzling. For 5 years, there is no drizzling in that particular town of Rajasthan. So he has not seen the rainy season. He has not seen the rain's precipitation, the person. And then he saw it after 5 years and saw what is this phenomena of coming water from the sky. So that was the thing. Of course, agricultural yield is, I mean something different, of course. Agricultural yield means there are, for example, rice. Rice needs more water. Wheat, these are our 2 main products, rice, wheat, and of course, bajra, that are still there. So they need more water, it doesn't need less water. But where we get more water is not getting water. For them, this monsoon, we have seen that the eastern part of the country has less monsoon as compared to the western part. I was telling eastern Hyderabad and western Hyderabad. So that is happening in our Indian system also. Some parts are getting more than the average, some parts are getting less than the average. It shall be a big discussion on this. Sea level rise. This is the biggest problem. We may face it. because our 20 or 25% of our population, India's population, live near sea coast. We have 7,510 kilometers sea coast. Of course, this subject is questionable because I work on the fractals, so I have studied this part. Fractal means zigzag. I can find out zigzag, length of a zigzag like a coastal area. So we have sent the paper to some of the journal. So the length of the coast will go up from this, what we have said, 7,610. But what I want to say is not for this today's program, I was trying to tell that 20 to 25% population of India is near coast. If that goes up, things will be in problem. I remember, Professor, we have a CCMB here in Hyderabad. Those people we are visited Hyderabad before NGRI, there's a CCMB. There's a director that time was Lalji Singh, who became later the vice chancellor in BHU. One day he phoned me, when we both had director, he phoned me, Dr. Dimri, we are finding some genes of Africa in Andaman. Africa in Andaman. How come the people of Africa would come to Andaman? That's the question I will not able to answer it. Professor of ISC CCMB director asked me. So what I could answer that, of course, there are other ways to come to India from the Himalayan side. That was being, we know it very well. But what argument I gave, of course, he published it. What argument I gave to him, that some time back, the sea level was low, not exist today. The islands were there, they were being visible. They can be, people are not staying there, but people that was in the upper side. So some people of that time, they would have taken a boat coming from his town of Africa to come to that particular islands, stayed for 1 or 2 nights, what was the possible, then come to this other island, other island. Like that, islands are become the stop for the what we call bus stop. This is a boat stop. So they were taking halt on those islands very easily, and then very easily they would have come to Andaman. So he liked it. He published the paper. Amna with the proper acknowledgement that was done long back. That is 15 years back too. That's the sea level check. Similarly, think increase of intensity of the extreme weather events, for example, cloud burst. This has become a very common thing currently. I have one example I can give because I don't know how much time I have. And one example I can give, one of the daughters younger daughter is in Bombay. So this COVID time, we could not go anywhere. I had to stay there for 3-4 months. And I was taking tea in the balcony. My granddaughter, who was that time 7-8 years old, she said, Nanu, my grandpapa, that today will be cloudburst. I go, how come you 7 years girl is talking about the cloudburst? What would have happened? The cloudburst has become so common in the system. In her school, her class friends was talking today with cloudburst. In our time, that frequency was very less. Now today the frequency is so much that even 7-8 year boy and girls can tell about the cloudburst very easily, that today it will be cloudburst. Whether it happened or not, that is a different story. But the word I am trying to tell, because it has become an extreme, it has become, frequency has gone so high that it has become daily phenomena. In any part of India, for example, there's some cloudburst is happening. Anyway, that is the thing we can think. Change in precipitation pattern among it. Recently, after I was writing this paper, slide, I saw one of the papers in Science that he has predicted, scientists have predicted for Indian monsoon that in coming years, in the next century, the precipitation will go by 8 times more. Suppose today's precipitation is a few millimeter in terms of centimeter, it will be 8 times more. In some part that we are seeing it. So that is the effects are coming up in many years. Of course, that started from after the global warming. Mass species extinction. There are a lot of paleontologists, they can understand it better than me. Effect of glacier. effect on glacier is again same story. Something happens in some part, it goes to Tapovan. Tapovan is very close to Badrinath. People may be knowing the Badrinath, and this is on the other side. At Joshimath, there are two rivers coming. One is Bhagirathi, other is Alaknanda from Badrinath. And if you follow the Bhagirathi side, you get the Tapovan. That is the last point. And there are, and that, you know, just 1 year back, this has happened. Before that, in Kedarnath, this happened. That is on June 13th, 2013, June, 9 years back. Changes in the timing of seasonal pattern in ecosystem. So that is also there. Seasonal pattern is getting changed. Of course, we are getting rainy time, rain. Of course, what is prediction of monsoon that is happening? Sometime late monsoon, sometime early monsoon, sometime normal monsoon. But the pattern is getting changed. Where the student rain is taking divert. Normal, when I was a student of as a special subject meteorology in my master degree, final year, meteorology. So we have been taught, I is being taught how monsoon comes from Arabian Sea. It takes start, comes to Goa, Konkan, Goa, Bombay, takes right turn, comes to my town, Hyderabad, goes to the eastern side, from Bay of Bengal, goes to the east. So that's not seen this year also. It didn't go to that side in the eastern side. It went up to Gujarat and Rajasthan. That is the pattern. Other effect of economic importance. If this happens, our economic importance is a separate subject. I was talking in some lecture in Gandhinagar, Gujarat. So I gave it my title, Hawa, Pani or Dawa. Hawa, Pani or Dawa. Hawa is important, Pani is equally important, and Dawa, that's economic importance comes here. So may I have the next slide, please? This is Kedarnath. I was trying to tell. And 1883, Kedarnath was only one building, and for the pujaris, 2-3 more buildings, and it is all ice. So what has happened in 2013, June 13 or 14, something like 13 or 14 June, it all happened, and the whole story is well known to us. And whether a small burning in some part of the India in the eastern or western has affected Kedarnath glacier, or within the Uttarakhand there's a fire in some way, and that fire makes some another non-linear system is a highly non-linear, a small perturbation in any of the region, any of the cause can change the global, can change the modeling. So it can affect the final result. That is non-linear, sir. Thank you, sir. Next, please. Now come to the point which looking for the solution. So far I told about the problem we have. Now let us see the what we can do as earth scientists. We should do. Capture and storage of CO2 in suitable place is attractive because of manifold advantage. It has some advantage. Geological sequestration of carbon dioxide is a means of injection of suitable geological forms. Why it should be done again, the research study, typically below 1 kilometer depth, where the temperature and pressure are poor, the critical point of carbon dioxide, that is the best place to store it. There are some many problems affected. Once you store it, should be there for 500 years. Next, please. This is the thing, this is a simple symbolic diagram where the CO2 can be injected and it can go. I'll come to this point later. So this is just the figure, so how sequestration means like that. Next, please. Fabulous traps. There are some, as a geologist we feel, we should tell to the nation, if there are places where we can do it. Geological reservoir for safe and long storage for carbon dioxide must meet certain criteria. Of course, there should be certainty. Unless that is satisfied, we will not recommend to the government to do it. As a matter of fact, I was mentioning to why FIGA was initiated. FIGA was initiated because of this reason, that we have to tell to the government with the force that you need to do this. They have no other choice. Some favored geological traps based on reservoir characteristics, such as here we have to study porosity, permeability, and their affinity for the chemical reaction is discussed. We are discussing these things. They are important for as our scientists. We have to see the permeability, porosity, so that is suitable, that geological formation for CO2 to store. Next, please. Perfect sealing, as I mentioned, is to preserve it for longer geological time. Once we inject something CO2 in the system, in the subsurface, it should remain, it should not come out. After, say, 500 years, it comes out, then where we are. We are safe, it's what we have done it. So we should see that it should be perfect sealing form where we kept it. It should be blocked. It should not leak anyway. That is the idea. Leakage of the sequestered carbon dioxide could lead to environmental disaster, that we understand now. The temperature pressure condition to initiate chemical reaction to carbonate of the mineral. There should be certain condition. If there is a calcium, there is some mineral. So the mineral plus CO2 can be calcium carbonate. So that should be the another stage should come. Another chemistry should be there. So that carbonate rocks should form. And that we have seen it. I'll show you that nature has done it. But now we have to do it. Nature has already done it. Carbonate after CO2 has not injected, it is poured out by some system, and with the mineral and carbonates are formed. Suitable, that is required, suitable porosity, permeability, and presence of suitable reactant like brine. That is a very important thing. Brine are some of the criteria of good sequestration site. These are some of the criteria. Time permit, we'll discuss them. Otherwise, next, please. A possible potential CO2 traps. There could be several possible traps for CO2 sequestration. However, fewer are discussed here. Basalt formation, we'll come to that. Shale formation, we'll say something. Abundant hydrocarbon reservoir. These also those already we have taken the oil and left there. You should not live like that. Put CO2 there. Safe side, because from centuries, from the many years, it was safe. I mean, the oil was there. We have taken out. So I'll show you some of the slides here. Saline reservoir, non-economic coal seam. Non-economic coal seam means those deep. We'll come to that point also. Brine oil field, that is very enhanced oil recovery. This is the thing I learned in Norway. Professor Bondi Garu mentioned that I was in Norway in 86 to 88. Yes, I did 2 years postdoctoral that time. Later I went for 9 months later, but for 2 years initially for doing postdoc. So I learned this EOR there in Norway with the Start Oil company. I was in the university, Norway Institute of Science and Technology. But next door was Start Oil, which is now the name has changed, which is a leading oil company in the Norway. So they were working there are some places they have picked up, and I understood there's a different type of, I used to give talk, I used to hear the talk of expert of the EOR. So that was the advantage I had in Norway in 1986-88. Next, please. Of course, I have left something. There are others. Deep ocean. You can inject CO2, but I am not an oceanographer, so I will not speak on that. There are deep ocean storage also exists. That we have another institute in CSI system, the Institute of Oceanography, that people have done some work there, but there are also some problems. In all these places, there are some problems. You have to be careful. One of the way forward is that we have to invest more on research on the CO2 sequestration, on the CO2 storage, on the CO2 enhanced oil recovery, or fossil storage, so the chemical chain. We have to spend some more projects by the government of India. If not government of India, some industry should come forward. They must investigate, like OMGC and other things. Okay, sir. Basalt formation. Large igneous clones ranging in age from the Precambrian. How? I'm talking about the basalt. All of us are, most of us are geologists, so we know the place. So what has happened 65, 66 million years back? volcano. Of course, there are two theories: volcanic eruption and something from the top comes. But we agree on the for the timing volcanic eruption, and then that time India was not that place. It was in the southern hemisphere. It moved to the northern hemisphere 66 million years ago, but not happened in 1 year. It happened for 1.5 billion years gap or something of that nature. Today, more than 500,000 square kilometers of Indian Peninsula is covered with the basaltic rock known as Deccan. I think the next figure, there's the next figure perhaps. May I have the next slide? Yes, this is the location of Deccan Volcano province. Here you can see the green part. One can easily see how big was this. And as a matter of fact, it was 3 times more, according to some of the reports, it's 3 times more than what we are seeing it. Some has been eroded, some has been, there's the ocean on the left side. So, and what is its volume? That is a question. The area I have to, volume is questionable. That is in the eastern side, it is few hundred meters. On the western side, as on today, is 1.8, 1.9 kilometer thick wall basalt. On the eastern side, it is a few hundred meters. So that's all about this. And the idea is that what is below Deccan Volcano? We have to investigate this fully. Again, big projects should be there on this. There are some institutions are working on the small, some 4 people, 3 people, 10 people. That's not it. It has to be done in the larger scale. The institute should be there to understand the volcanic problems of the country, so that we can understand it properly. Where are those places where we can inject the carbon dioxide? If I remember when I was a student came to NGRI, some high altitude aeromagnetic survey was done, 4,000, 5,000, 7,000 feet from the mean sea level to find out the thickness of the basalt, so that we can know its volume properly and its extension this way, that way. So that was done, and we did it, we published the paper, and verifying it is also important. Verifying, because geophysics is it can give one of the answer of 2 or 3 answers. So we have to concentrate to one answer, one thickness. So that was drilling is one of the solutions. Of course, some drilling has been done in the GBPNIHE area by NGRI, of course, and with the support of MOES in Delhi. So that was the done. We have to know where we can inject. So what is below the Deccan Trap? That's also possible. We have oils in particular set of geology. What is below the Deccan Trap is that geology which matches with the other part of the country. So definitely there should be oil below the Deccan Trap. But again, the question is, 65 million years back, whether it has been exhausted or it has been evaporated or something, and then that place is good for CO2 sequestration, CO2 storage. So there are many scopes for CO2 sequestration without harming the nature, without harming our environment. That is our main criteria. What we have done it for last so many years, we have killed the environment. Almost we have killed it. The only thing is we can still work, because now it's globally understandable that we have to work very hard on this. Next slide, please. Yes, our NGRI people has done good work. They have taken geological and geochemical analysis, and then they found very good nature. For example, already carbonates are there. So those CO2 is already injected by the system, and there are some minerals, and combining with that, some carbonates are formed. As I told, this has happened not in one day, in 1 million years, not in one go, this volcanic eruption. It was done in some 1 to 1.5 million years, some 50,000 something years there. So within that one, when there is nothing eruption, sediments are deposited. sediments are deposited, then are getting volcano. For example, this figure 2. So we call it intertrapez. Intertrapez are there below basalt, sediments above basalt. So it is well seen. Below also it cannot go down, it cannot go up. That is the best place, intertrapez. But again, there are questions we will come to know. Not today's lecture, but in some other things I can talk later also to our society. Once I become a member of society, I can talk to you later also. Next, please. Yes, this is what I was trying to say. So some Maharashtra, this NGR work, they have done it and they found where are the places where particular we call vestibule zones are there. So those are the places. I will not say these are the places, a massive zone. Below that, there are some places we can work on those. Next, please. Another attractive alternative is that, as mentioning, Mesozoic sediments below Deccan Tract. As most of the oil in Indian area is on Mesozoic sediment. It so happened that the below Deccan Tract, we have same system, Mesozoic sediment. So that is the real place of the oil to be accumulated. Whether we should try there. So to find out the thickness of the thing, we, NGRI and ONGC, worked together for a couple of years, and we did some deep survey along this particular area in the eastern part of in the western part of Deccan Tract in the Gujarat area. Next, please, Western India. For example, this is done there, and we could find out the thickness of the sediments. We are talking sediments, not the Deccan Tract. Also, we would have found, and plus the thickness. And let us say in the next slide, I think it is clear how it works. Suppose on the one section, we call profile. Next slide will show the profile. For example, this profile from one place A to place B, and you can see the different colors are there. The first one is sediments, that is alluvium, we can call it, and then comes from Deccan Tract, for which the thicknesses in different places, thicknesses are different from this point to that point, and then Mesozoic sediment, which are trying to take sir. These are the things we are looking for, Mesozoic sediment, and below is of course basement. That these are the good place, because above Deccan Tract is just the intertrapez situation here, and below also basement. So these are the places where the Mesozoic sediments are. The Mesozoic sediments, I am trying to repeat it, because these are the places where in India, whether you go to the northeast, whether you go to Gujarat, other part of Gujarat, you will find the Mesozoic sediments. We have oil in that, and here we can think it, because just below the Deccan Tract are those favorable situations for Indian subsystem where oil can be there. And if it is not there today, need not worry, they have gone it. So they are the place for CO2 sequestration, CO2 injection. Next, please. Like that, we have shale formation. The most common sedimentary geological formation is the shale characteristic by thin lamellar beds. This is also one of the best part. Shale generally have very low vertical permeability, and almost all kinds of shale have low percentage of organic material, which provides a surface, for carbon dioxide absorption. This can absorb CO2 very easily. Then similar to coal beds is a similar story like shale formation. Shale coal, another option for carbon dioxide sequestration, but low permeability is the major challenge in this case. But again, the research is required here also. We cannot just say by shale whether shale is there, you start pouring the CO2. No, we have to do a lot of studies there. As I was telling you, a separate institute must be there for the climate change, for this sequestration. Next, please. Non-economic coal seam. As I mentioned, in 1912, in United States, somebody writes, these are the one possible cause of CO2 emission. I had been to Dhanbad, Jharia. I have seen a lot of coal mines. I had been to coal mine. I went up to 1,000 feet. So now I know what is that typical things. So some of the coal seams are not economical. There are non-economical. It doesn't give profit. As I had been told, what is the definition of ore? Ore is defined as a profit. That word is still, I remember. Ore is defined when the extraction of mineral with profit. With the profit, what is exists today? I was taught 50 years back. That is today. So with profit is not, if there is a coal without profit, that's the right place to put the CO2. Such coal seams are favorable places for carbon dioxide sequestration. They are the best places to put carbon dioxide. Coal has very high porosity to accumulate huge amount of carbon dioxide. That is one situation. All coals have a very amount of methane absorbed into pore surfaces, which is also potential energy resource. That is it. I think coal with methane. I think the next slide will make it more clear. Next slide will make clear. Well, can be drilled in the coal bed to recover the coal bed methane. Is another source of energy. Coal bed methane. CBM recovery can be achieved by stripping the coal bed with the carbon dioxide. This can be also increased. CBM recovery can be done if you inject carbon dioxide. Carbon dioxide preferably absorbed into surface of the coal, releasing the methane. That is the advantage of putting carbon dioxide. Mind it, carbon dioxide putting, there are some disadvantages. I may have time or not, I will tell you, but that has to be seen properly. What type of carbon dioxide we are injecting here, whether it is pure or impure or something added with that. So be careful on that aspect. So next slide, please. Abundant hydrocarbon reservoir. I was just mentioning this. There are the geological settings in which the oil and gas was trapped for long geological time. What happens? Of course, our oil field in India, for because we are talking about India, we have a big boy right from long back in the eastern part of the country, and then we have, after ONGC came into the picture, we have the Ankleshwar oil field in the west. So we have taken some of the places we have taken, and not 100% we cannot take. So 80, 70, 80% of oil we have already taken, and there's no scope because it's not economically feasible, economically beneficial. So we hold it and we leave it some oil there. So those that we call abundant hydrocarbon reservoir, we are not interested in those. So those places, let us identify. ONGC, we and others can also identify those places. All India company can identify this. Those are the places where this can be done. But mind it should not come out. That is our primary condition. It should not, after 100 years, it comes out from some other corner. So it should be leaked through. These abundant hazardous reservoirs are the best possible locations vacated by the natural oil and gas where carbon dioxide can be stored very easily. So I still watch for this particular thing that already we have taken the oil, and for centuries from the some years together, oil was preserved until we started discovering and extracting it. Oil was very safely over there. So once we have taken, why not put the CO2? It's already taken oil, now CO2, but see only that leakage should not be there. Next, please. These reservoirs have proven capacity of which I was trying to holding natural oil and gas and have a good sealing. That's the already sealing that is important because nature has. We don't have anything Jwalamukhhi, that is a different story in the Himalaya, in the other place. So, but we didn't get anything there. Where we have some not sealing, some leaking is there, but that is a special case. We will not talk on this just now. Under high pressure, carbon dioxide turns into the liquid supercritical carbon dioxide. When injected in the reservoir, it's trapped low and the sea level is get trapped. That's the idea. Next, please. Saline reservoir, this is equally important. Many places in the world, people have started thinking in that direction. Another interesting possibility is to restore carbon in saline brine filled reservoir. It has an advantage. Besides getting stored in the pores, carbon dioxide molecules also dissolve in brine and react with the minerals to form solid carbonate. That was I was trying to tell. In Deccan Trap, we are already seeing it. We have seen eternal, what is the name of the town of some formation. We have seen that there are 4 or 5 places our engineer has done geochemical survey in that area, observed in the pores of the portion. But there are some problems, but that problem has to be solved by this, by they call hydraulic fracturing can be done. Hence, injection of CO2 in saline deposition can be a potential hurdle, but solution exists if you really think in that direction. Next, please. This is a very important, a separate talk can be given, and this I learned in Norway. And as one of the professor was telling, my student, Dr. Partho is listening also. He was we did together some work, and he did PhD from Osmania University in Hyderabad, if I remember correctly. So now he's in IIT Kharagpur currently. Earlier he was in the Train Energy. So before that, when we in contact, that time he was in ONGC. So ONGC and NGRI, right from 2003 or 4, we started working together on this after I returned from Norway. Next, please. I have not done much here. I'm not giving much detail of this because it needs a separate discussion. A brownfield sequestration carbon dioxide becomes an additional advantage because it helps in enhance oil recovery. The additional advantage: one, you are injecting CO2. Second, you are getting oil. So you have in one go you are getting 2 things. You are injecting CO2, means you are lowering the concentration of the CO2 in the atmosphere. First, we have to transport it. There are some places where the CO2 is, chimneys are there. From there, you can transport to the nearby oil field in Ankleshwar or whatever you field, brown oil field, and then inject it. So that is the idea in that. Injected carbon dioxide dissolve the oil and reduce. So why scientifically it is like our Indian oil is heavy. We have heavy oil in India. Many places have heavy oil. So we have almost all of the oil fields heavy oil. So if we viscosity is the other side. If you reduce the viscosity, then it will flow. Otherwise, it is standing still. Well, because it's not moving. The oil which we see in most of the Indian oil field is with a high viscosity. It remains where it is. We have to find out the way to find out. One way is to inject CO2. With injecting CO2, the viscosity will come down. Viscosity will come down, it will move, and then take it out. That's a simple logic in this. This is indeed one of the best known commercially viable methods to enhance the secondary recovery from the oil field. This is the brief I was trying to tell. We have to reduce the viscosity of the heavy oil so that it flows. There are many ways to do. Let us see 1 or 2 ways. Next, please. Carbon dioxide injection for enhanced oil recovery. This is what being done. We inject, we transport it, anthropogenic and natural, or we inject it. Anyway, and then it goes to the side and we recycle and again back. So keep on doing. CO2 comes, suppose CO2 will come, some CO2 will come, we bring it back to the system. So that's the normally is being said about CO2 for enhanced oil recovery through CO2 injection. Next. Of course, we don't have any case studies. This is, but we have been attempting, has been made many times by different methods. In Norway, in Canada is there. As far as I had a chance to talk to my friends there and listen many lectures. So there is another way of we call in situ combustion, thermal recovery techniques. Till we have some problem with this, we can think of in situ combustion. So similar to CO2 injection, this is also successfully attempted in India. Next, please. Here, what we do, we burn the front of the oil. I was trying to mention, it becomes lighter. Once it becomes lighter, it moves. One move, comes up. You get oil. Of course, oil and water will get it, but that we get now. So that is a not big problem. So injection of CO2 on this side, air and water and some minerals, so that it burns the CO2 and it reduces the viscosity. Idea is to reduce the viscosity. It flows to the way this side, on the other side, where there is a deep well, it comes out. So that is your, you get to recover the oil in front of you. Next, please. I think there's one more, any other. So I have come to almost a conclusion. The public awareness of detrimental effect of global warming and its mitigation step is a vital part to overcome the increasing carbon dioxide. Plantation is one such solution. So this is the thing. One Mahotsav has been introduced in our country by the Honorable Minister of Minister. Recently, I saw in Google search regarding plantation. So plantation is being done, but it has to be done in a bigger way, in a larger scale, so that we know the history is like that. I have one slide there also, where it started in Chipko program in the Uttarakhand, because I come from this. I have an example of that place. But there are fire also, there are pine trees also. That is another story for that part. But plantation is one such example where we can really think we can start working with that. And every individual should plant, at least one individual put 10 plants, so million plants should be here and there. Anyway, the measure of mitigation of the global warming must be implemented from individual to national to institution. So individually has to be. So all of us should be equally careful that it's going to be a big problem. We have the solution. Solutions, either we do something on plantation or there's some other way. I forgot to tell, there are some other CO2, there's a thermal, what do you call it? If you inject CO2 in a system where you can get energy, what is in the subsurface. So thermal plants can be also made of CO2 sequestration. I think it is not come here. Let me be more clear. If you inject CO2, and as you know, when you go down, the temperature goes up. So there is a thermal energy in the subsurface. So that thermal energy, we can bring it back to surface, and you can use it for many purposes. Thermal plants, which is again it doesn't harm anything. For example, the hydro plants, energy, coal energy problem, electricity makes a problem. But there are some there are some energy like thermal energy, and it doesn't have any problem. So there is the advantage of CO2 sequestration for thermal study. So again, we have to work very much on this type of study. Anyway, so every individual, each of us should go, each nation should do, because it's not that I'm not responsible for CO2 emission. That was some thinking of some countries who have not done it. But you do or not do, it's going to affect your country also and your people also, and international. Next, please. Geological sequestration of carbon dioxide is reduced global warming is an active area also. This I'm trying to tell since beginning, that we have to work, whether an institute may be open, whether an institute of Department of Science and Technology, some institute or DST or CSIR or some institute has to open on geological sequestration of carbon dioxide. Or what do you want to remove? Geological sequestration of capture somewhere in this country. And as in the mentioned, it is not only geology. There are many, you can see it, chemistry, biology, all things, the environment people, biodiversity, they do come in picture. So there should be, all should be mixed up and come for a solution for India, for the safety of us, for future generation. Future generation should not tell that my grandpapa has done this wrong thing. Abundant hydrocarbon reservoir, saline reservoir, non-economic coal seam, shale, basalt formation, and ocean, which is not written here. Deep ocean is also, but there are some questions there. Every has all things have a question. It's not that straightforward. So every all alternative, all the places of trap have some problem. So we have to give over this. Our promising candidate for carbon dioxide stories. But if you do in oil, you get the 1 and 2. Next, please. Carbon dioxide injection serves two purposes. One, to reduce CO2 from atmosphere, other to enhance the oil recovery from the oil field. And one more I can add it, one to reduce the CO2 inject CO2, and other to increase your thermal plants. You can make thermal plants here and there. There are so many places. So, but research has to go. Only to telling it does not sufficient. So we have to do research. I have done on EOR and Deccan Trap, Deccan Molecule, right from 1976 when NGRA got airborne survey. So I started working on Deccan Trap method. Next, please. This is about the Chipko argument. When I was 8-10 years old boy in Uttarakhand going to school, I used to see the woods being transported in the Alaknanda River. My house, just you can see the Alaknanda River from my balcony of my house in Chamor area. You can see. Used to see lot of woods are being transported. Lots of wood. When I used to ask my parents, they said this is cheaper way of transporting. Then the transport by the truck. Other truck has to truck or some, there's only truck that time. Truck has to transport from say top high altitude area to the down to Rishikesh or Haridwar. So this 250 or 300 kilometer transportation is huge about, the price will go up. So this is a simple, this river channel is used. That's the idea of that time. But there are some people in that area, they hugged the tree, they didn't allow the tree to be broken. And in that one, Chandji Prasad Bhatt was the first, and Bhoganaji was also a follower of that. So they started Chipko Great. They both came to NGRI when I was the director of this. I invited both of them and they planted the tree. I didn't have the photo of the Chandji Prasad Bhatt, the plantation, but Bhogana plantation is there. He is planting a tree in front of our, in NGRI. I was helping him giving a mud and other thing. I was planting a tree. The tree is still there. Whenever I go and see the tree, I salute the tree because done by Padma Shri Sundarlal Bhogana. 2 years back, he expired, unfortunately. So what I want to say, sir, even one plant, this is the indicator that we have no other solution. Sequestration will take time. Plantation is not going to take time. So we have to do in that direction. I think I'm closing within 45 minutes. So with the next slide, please. The entire work is done by CSI and GRI. Thanks to all my PhDs and lecture there and others, CSI who have the main contribution of this work. I have not shown the EOR in detail. If our committee feels that sometime need not to be in this sequence, some other sequence I can talk about, because I thought there may be not much people from oil industry here. People must be from the geological teaching geology. Oil industry people, it's interest. But I can talk on EOR, that is my personal subject. So one day I can talk on this. So with this, I thank you all for giving me this opportunity. Next, perhaps thanking you all. Thank you all to the society for giving me opportunity and for listening to my 45 minutes talk. So, thank you, sir.
Thank you. Thank you so much, sir. Thank you so much, sir. I, on behalf of all the distinguished participants, convey our heartfelt greetings and congratulations to you because it was a brilliant deliberation indeed. You have dealt with two important aspects, particularly global warming as well as carbon dioxide sequestration. And you have tried and you have established successfully how carbon sequestration can reduce significantly your global warming, the effect of global warming. So now I find there are a lot of questions in the chat box already. So without wasting much time, I now invite Dr. B.M. Farooq to please come forward and start.
Yeah.
The
If
question
there are
and
more
answer
questions, they
Dr.
can
Farooq,
send me email also. I have
Okay,
email
okay.
address vpdimri@gmail.com.
Okay, sir. Okay, sir. Let us see
Okay.
how many we can accommodate.
How many you can accommodate if
Thank-
there's some time restriction for the other learned listener. So they can send me email. I can answer them also through email also, or one or two questions can be here. No problem, sir.
Thank you, sir. Dr. Farooq, please.
Yeah, well, I thank Mr. Sujit Mahanti, but I cannot thank enough Dr. VP Dimri for this excellent talk, for this lucid presentation, and for lacing it with your anecdotes from your experiences. Thank you, Dr. Dimri, for a wonderful talk and a very informative presentation. I will now, as a moderator, my job is not only to pass on the questions to you, but I think there are questions which also need to be. What happened?
No, nothing. My wife is coming. No problem.
No. Actually, I was actually my chat box.
No, please go ahead.
No, my chat box doesn't show questions.
Now, people are free to, they can send me email.
There are 13 chat box questions, Dr. Farooq.
Yeah, but I don't know why it is not showing in my.
You click chat,
Yeah.
then you will get
You
the.
just click. No, every time you do that.
Yes, you click the chat. If you are not getting, then I can read out.
I think that is. Yeah,
I think it's better.
It has got. I got it now.
Okay.
No, it was actually blocked. Okay. My job is not only to pass on the questions to you, sir, because I find that some of the questions are okay, relevant, but those which are not, I think, relevant directly to the talk present, subject today, have to be filtered out, perhaps, unfortunately. And now is only a question from Jivantika Kumari. She's asking, is only CO2 the cause of uneven monsoon? Here, I would like to say that, well, when we are talking of global warming or the monsoon, uneven monsoon, we are not talking of so many other factors, because those are not to be discussed in a 45-minute presentation. So it is probably not possible to touch all the aspects of, reasons of irregular uneven monsoon. The next question is by Mr. A.B. Panigrahi. Professor Dimri, what quantity of CO2 is absorbed by afforestation of 1 hectare area with 1600 matured trees? I think, again, this is more of a forestry. It should be addressed to, I think, a person who is dealing with the forest. I think to ask this question to a geophysicist will be unfair, I will say. But then we can find that.
I can answer that monsoon because I have a special subject.
Okay, please.
At monsoon at master degree,
Okay,
50
please.
years back.
Please.
So what happens in monsoon? First, it starts from the word mausam. That's why the word monsoon. That was taught to us 50 years back. Mausam, monsoon. So, but now you see what is the parameter? There are many parameters which talks about monsoon. So even on 26th of, that 1st June, it has to hit Kerala, or 29th of May, around that. That's the normal. On 26th May, what was the temperature in the Norway, where I studied? I had my postdoc. So the temperature of Norway on 26th May is one of the parameters of for the monsoon on time. Mind it, Norway, where Norway is, the highest latitude, I was in 64 degrees. This is 66 degrees. 66 degrees longitude. What was the temperature on the coast on that day? If that matches with that one, then that year the monsoon of India will be better. Because monsoon, the waves come from that side, the Pacific Ocean, and then come to Arabian Sea, and then takes turn, and then come to the Bay of Bengal and our East Coast or Konkan, what we call it, or Kerala. So there are many factors, many factors which affects monsoon on time, or what World has used it. It's not on the right time, right.
Uneven.
What World has used it. What was World has
Uneven.
Uneven.
monsoon.
Uneven.
Because uneven, that depends on the what is happening in Norway on 26th May. This is one of the parameters. There are, if you see the model of the monsoon model, there are 26 parameters, but now we have cut down. Now only 8 parameters left, because it is difficult to work on 26 parameters. We need a computer of high profile. So we are working on 8 to 10 parameters, like IMD, India Meteorological Department of Government of India, which is one of the oldest system in the country, is working on 8 to 10 parameters, and that, or maybe I don't know, they can increase or decrease the number of variables parameter, and then accordingly they can predict the monsoon. It is, and even then, sometime early, sometime late, sometime normal. They are there, and then again, which way they are moving. When the sea gets warmer in the month of May, what was the temperature of in our Indian system? What we know it. If this year we call it, this year weather is good, when the temperature is high, so we get a good monsoon. But I'm talking of the Norway, sir. This is one of the parameters what we were working for many years to see the Indian monsoon, because the current starts from there and then monsoon comes here. So what, of course, they can send me an email, no problem. I can answer, see it here.
Dr. Farooq, we can move to the next question.
Yeah.
Yeah.
We come to the next question. Mr. Vinod Srinivasan. Sir, what about sequestration in granites? We have good resources of granites, and there are many research on storage of CO2 in granites encountered in geothermal system. What potential we have here in India on granites?
Yeah, this is a good question. Actually, I could not cover all the things. I kept only basalt from. But these are other alternatives are there. There are many alternatives. But only thing I was trying to tell to my researcher that before recommending to the government that put their CO2, we have to work hard. We have to work a lot of research on that, because porosity, permeability, they are the parameters of the rock. We have to look very so that CO2 can absorb it to the carbonate to form the chemical reaction. Chemical reaction and the carbonates are formed. So all these possibilities are there. And thermal is one of the things which we should start. We are not working. At least I don't know who is working in the country, but there is a lot of scope for that. That not only the hot spring I'm talking. Hot spring can be seen that there is a high temperature because it comes from the down. But there are places where it need not be. It could be in Hyderabad also. But
No, probably you mean geothermal energy.
Geothermal energy, of course.
Yeah.
Geothermal energy.
Yes. You are missing that word geothermal. You are talking of geothermal energy.
Yes, geothermal energy can be done through CO2 sequestration also, but not what has been done.
I think the question here is about granite business, Dr. Farooq.
Yeah. Granite question is being dealt now.
Okay.
We are through with the
On
question.
the iron ore, there is a question.
I am coming to the next question. Any live example of CO2 sequestration project in hand from Mr. Satidananda?
Yeah.
Any live example of CO2 sequestration project in hand?
Yeah. What happens? Simulation we are doing. Simulation.
Okay.
Simulation in the computer based simulation we are doing, and for example, we've done Belul oil field, NGRI done Belul oil field in Ankleshwar. We have done a lot of things in Ankleshwar, but mostly on the simulation basis. On the exact CO2 sequestration that it's not known to many of us, because it has to be agreed by the government of India first. That's what I tell. FIGA is the place where we can push it to the government of India. We have an institute of CO2 sequestration in India.
Thank you. I think Thank you, Dr. Dimri. We have one Mr. Rabin Aran sir, who would like to compliment something on the Deccan Traps sequestration in Deccan Traps. We'll come to him after we have finished with other questions. We'll come to you, Mr. Aran sir. Dr. Mansingh, Dr. Lalu Mansingh, asking you, what are the required geological properties of a geological structure for sequestration? Is there a depth limitation?
Yeah, yes, sir. Yes, sir. Yes, sir. Because yes, of course, I try to mention in the slide that at that particular temperature and pressure that, that I mentioned in one of the slides.
Yeah,
so, for example, tentatively we have given some 1 kilometer or so, but there is.
31.6 is the temperature and 7.38 psi.
One of the slides.
Yes. And next question is, what are the methods of collection and injection of CO2? These are, I think,
transportation is a big question. What is being done in Norway? We can follow it, but we have a different things at this point of time. For example, chimneys, cements. We can see a lot of chimneys are there and the CO2 goes up. So we have to transport from there to the some oil sector. Say Ankleshwar. There is all. Of course, we have in Godavari also oil here. So nearby, nearer. Otherwise, it will be too costly. So we have to transport it from A point to B point. Again, the transportation needs again some good studies. So we cannot just put it there and it comes to this other side. So that particular temperature and pressure has to be maintained properly. So what I am trying to tell that it's a lot of research is required, and some of the institutions already started working with it. But one vision, we have to do it. That has to come.
Thank you. Another question from Dr. Lalu Mansingh. Can the volume of potential sequestration match the current total CO2 emission?
Current social emission, for example, I mentioned that is 419, actually it's 420 per million hour. IPC 420 is not right. 319, 19 ppm. So, and it is so huge amount, so we cannot do it in one go. It has to be done by all countries. Not only India can take it. India can take a lead, but it has to be done by all countries.
Next question. Thank you, Dr. Dimri.
All countries should. I did mention individual, national, and international. All countries when come together, then only this is possible. Otherwise, not possible. If India started doing sequestration, doesn't help much. It has to be done by China. It has to be done by Norway. Is doing by other countries at the same time.
Yeah. Next question is by Dr. Rajgopal Mahanti. Again, there is a deviation from geophysics. Is there any specific plant species which absorb more CO2 than other plants? I think it should be addressed to.
Yeah, that's why this is a problem of multidisciplinary.
Yeah,
it is this problem is not only our scientists can do it. The biodiversity person, as you just mentioned, this question. So, what are those plants which can absorb more than the pine tree in the Himalaya? Pine tree was stored by the Britishers during that time. But the best tree would have been different, but they did it for different reasons. Anyway, that's not quite to be discussed for this question. This question is there must be some plant which absorb more, or there are some plant because the whether leaf should be bigger, whether the leaf should be one pine tree. Pine tree, if pine is just one needle. One, if you remember, if you have seen pine tree, and if you have seen oak tree is also very famous tree. Oak tree, what is done in oak trees in UK, it is also in Uttarakhand. Oak tree is better. I don't know, but could be. But there may be some other tree also. So this is a good question, sir. That's why I'm telling it is a multidisciplinary approach. One geologist cannot solve this problem. He has to be supported by biologists, he has to be supported by chemists, as you mentioned, at what temperature CO2 should be, at what depth should be there. It should be chemist, geochemist, geophysics, geologist, also. An institute should be there if India wants to do it.
We fully agree with you, Dr.
Yes, sir.
Next, we have got a lot of compliments to you. I'll be reading out, I mean, it is representing all the participants, though it is written by, say, Mr. Jadav Nanda Das and Dr. B. Mishra. Excellent presentation by Dr. VP Dimri on a very thought-provoking subject. Thank you, sir. Next, we come to a question by Dr. B. Mishra. Are iron ore group of rocks like BHJ, shale, and phyllites, etc., of Joda and Berbil area of Kenjur district, those are places in Odisha, horseshoe iron ore, are feasible for carbon sequestration? This area is highly polluted. Well, I think it need not be locally attending to local pollution only.
Yeah.
So this is the question. If these are these rocks BHJ, banded hematite jasper, shale, and
why we
phyllites.
are interested for Deccan Trap? Why? Because the reasons are simple. Nature has also accepted it. But there are, if you put a drill there, or if you see another section as a function of depth in Deccan Trap, you can see it. There are some carbonates there. How the carbonate would have been there? There are we got intertrapians. They are solid on the top. They are sealed on the bottom. That is must, sir. We want a sealed one on the bottom. Nothing can go down, so that it should come from other side. And nothing at the top also. Nothing should leak it. So these are the why Deccan Trap is there, because it has a geologically favorable situation. We can think it. Or the intertrapians. I am mentioning intertrapians because this happens, not happens in one go. It happens in intervals. So during interval time, there are sediments are there. Those sediments, I showed one of the slides worked by NGRI. There are 1 kilometer depth. They are the best place. But again, we have to see on the left and right, on the other side, should not leak out. So after 100 years, it comes out where we stand, same thing, no problem. And today we have solved the problem, but tomorrow it's not so unsolved. So point of some other sources, we have to think it, whether if CO2 is there, what will happen to those areas? Whether after 50 years it comes out, or it remains there intact, or it gets mixed up and forms some other minerals. That has chemical reaction. It forms some minerals, carbonate, for example, that is seen in the Deccan Trap. That's why we are favoring Deccan Trap.
Basically, we will be targeting calcium and magnesium in the formations so that it combines and forms calcite and dolomite, or anchorite with magnesium, iron, and other elements. So, and then it is fixed permanently.
There are many other reasons. So, but science, for science, we have to do research. Kaam karte rahe.
And then again, another compliment from Mr. A.K. Raut. Then Dr. Harsh Gupta has an excellent coverage. Dr. Yeah, he's listening. An excellent coverage of the most important issue that Mother Earth is facing. My compliments. His compliments.
Thank you.
Next, Mr. Partha Mitra. Granite being, well, tighter is not the well, may not be an ideal candidate for CO2 sequestration. That is his answer to the first question. You know, previously there was a question on granite.
Yeah.
Now we'll come to Dr. Sudhamai. Temperature, dust particles play a great role in cloud formation. Then with increase in CO2, which leads to global warming, affects our climate system, particularly the rainfall pattern. Kindly throw some light on this regard.
Yeah, he's correct. When I was talking in the beginning, there is a positive forcing and negative. Aerosol, which I was trying to tell particles. That particle comes from our surface. That's called aerosol, the particles. Those aerosols, because it stops radiation from the sun. Actually, sun is the important. What has happened in the past, if the sun was nearer to us, temperature was high. The sun was away from us, temperature was low. That has happened in the past, in the hundreds of millions years back. That what I told about how the people of the Andaman, Ankleshwar, Africa came to India. That is the story in that. And coming to his question, the aerosol are negative force of climate, negative force, but there are big questions on that. Why aerosol? We are totally responsible for that. We are not dependent on that. Otherwise, we start throwing aerosol on the atmosphere. No, sir, you should not do it because it has an effect. It can change the pattern of the rainfall, precipitation. It does change. If there are more of aerosol in some part of the globe or some part of the country, the pattern of the rainfall pattern will definitely going to change. So aerosol is negative forcing. It will reduce the global warming, but it has a lot of negative points which we can not balance it properly. But there are climate modelers. I think the professor who has asked this question, he may be climate modeler. So where aerosol does play a role, but it has an effect as a geologist, as a meteorologist person, which I did. So it has some effect on the pattern, on the rainfall pattern.
Dr. Farooq,
And
it's already 8
Dr.
o'clock.
Dr. Sudesh Vadhavan,
Yeah, please.
former DG
Go
GSI,
quickly.
can we dissolve CO2 in oceanic depths and transform into carbonates?
Ocean. Ocean.
Yeah, ocean,
Yeah,
oceanic depths.
promising area to put CO2 on the ocean. But again, sir, trying to tell these all possibilities we are talking about, it has some also negative aspect. So unless we read those negative aspects, CO2 we can put on the ocean, no doubt. And we are, our NIO, National Institute of Oceanography here in Goa,
Right.
they have done a lot of work on that. If I remember, Dr. Naqvi, I think, he has done a lot of work on that. So, but negative aspect, you are, again, purity of the carbon dioxide is also important. This part it didn't come in my talk. Purity of CO2 is also good. If CO2 is not pure, it is mixed up with some other thing, it's going to become a big problem for ocean or any other formation. CO2 has to be pure. Who will make the CO2 pure? Pure means when we have a CO2 emission of it is not only CO2. CO2 is mixed up with other things also. So this is a good point. There's a lot of scope on that, but research has to be done because if I remember correctly, the United Nations didn't approve this. United Nations didn't approve this CO2 sequestration in the ocean system. Because otherwise, other countries in the West would have done it long back. They didn't approve it, if I remember correctly, because I've read it. And I have any. Please.
Thank you, sir.
I
I
think
think
we'll
we'll have
faster now,
to,
Dr.
yeah,
Farooq.
we'll have to wrap it up with this question. I am sorry, but I think
Well, Dr.
our
Farooq, can I ask a
learned
question
speaker-
from Bangalore? Hello? Can I ask a question?
please, actually, I have a question at hand. Let me finish with it. I will come back to you. Please, you can post it on the chat box, please. Okay. Mr. Professor S.N. Patro has a question. Sequestration of carbon dioxide by forest is inexpensive, natural, and sustainable. This has been one of the commitment of India's NDC at Paris Climate Conclave. The target is to sequester.
Please repeat. He's asking to repeat the question.
Okay. From Professor S.N. Patro, sequestration of carbon dioxide by forest is inexpensive, natural, and sustainable. This has been one of the commitment of India's NDC at Paris Climate Conclave. The target is to sequester 3 billion tons of creation of adequate forest cover.
Yeah, yes, I did mention about this point that plantation is one of the solutions. But again, the question is, in India, we have also started Banotsav, in Hindi is called Banotsav, so that we should plant. Wherever we feel things, we should plant. But even then, if you cut one tree, we have to plant 10 trees. There are so many issues has come in our news items. Suppose I cut one plant for making my house. So either I should transport it. This tree can be transported. This tree can be transported to other place, say 1 kilometer away from here in the jungle. Or I should plant 10 more trees. This is, I don't know whether it's a rule or it's by default, or it should be. It is there, it exists. So what Professor was studying, the forest is of course by nature. If unfortunately most of the forests are being burnt here and there. So, but now people are aware of that. As I mentioned, Chipko Andolan is the awareness of the people. Maybe for their personal reason, they didn't want that they hugged it. But today that has become the landmark. In the Norway, that has been praised like anything. When I was in
Thank you, sir. I'm afraid we are running out of time and we may not be able to take all other questions. And our learned speaker has already given his email ID. So I think I will suggest that other participants with those questions can come, can go to him on the email and then get the answers. I'm sorry. My apologies to all the participants who have put the questions and I'm not able to contain them. So thank you, sir. Thank you. Over to Mr. Sridip Mahanti.
Thank you so much, sir, again for answering all the questions, but whatever is left can be addressed later on through your mail ID. And also I thank profusely Dr. Farooq for conducting the session very nicely. Before I request our General Secretary to offer a vote of thanks, may I request our President, Professor Mohanty, to give a brief concluding remarks, as well as we can also offer an e-memento to our distinguished guest as a mark of love and respect. He has to do two jobs now.
Thank you, Sujit.
Yeah.
I don't think that I have anything very special to add, except to say how delighted we are and how fortunate we have been to have listened to one of the authentic voices on a topic which is of great interest to India as well as to the rest of the world. Amrit Mahotsav and the 75th year of the independence is, of course, a very important event, but it is also equally important that 2015, when the United Nations started the SDG, the Sustainable Development Goals Program, and India became a signatory to that. So India also therefore pledged itself to all the goals and the targets, which are roughly another 10. So 17 into 10, you are talking of roughly 170 targets, 17 goals. We are all aware that the 13th goal of the SDG list is the climate action. And so therefore, it is not only important to this country or that country, it is to the whole of the world, because now we are not seeking, or we are not talking of economic development alone. We are talking of a more developed, equal, and secure development for the whole world by the year 2030. And out of this 2030, let us recall that we have come to 2022 already. So which means out of the 15-year period that we decided that we should be tackling various programs and the goals, only 8 years are left. So actually the time is greatly running out. And not just that, as they say in thermodynamics, we have passed the stability now. Many people or many scientists do believe that the point of recovery may be actually extremely difficult when it comes to the climatic condition or control of that. One of the points which I cannot help mentioning over here, Professor Dimri covered the entire gamut of the activities extremely well. And he did mention that CSR itself, he having been there, and also I do see one of our earlier speakers, Professor and eminent Professor Harsh Gupta, Professor K.C. Sahu. These are our former speakers of the DLG. They are all present here today. And we all know that our NIO Goa, as Professor Dimri mentioned, when you are talking of the OCS or the ocean carbon sequestration process, either by the direct injection or by ocean fertilization, which is the photosynthetic fixation. Many of us, we have been talking about that. So therefore, there are special plants and so on. And that is not completely explored as yet, which means India should be looking at both these, the ocean sphere as well as the geological sequestration, and they are not inseparable. They are not separable. They are actually connected with each other. And hence what we have found out today is it is truly a fitting title or theme on which you have spoken. And I would like to once again join all my colleagues, all the listeners, participants in thanking Professor Dimri for having aroused a lot of interest in this area, excitement in this area, possibilities in the area. But at the same time, we all realize that it's not easy at all, because when US struck, everybody thought gold by the hydrocarbons which are solidified, or the hydrocarbides, and people said that 1 cubic meter can provide the entire energy for the whole of the city of New York, for example. But that is a far-fetched notion as yet. So this is an area in which climatic change and the energy, whether we can actually tackle both of them. With that, I thank him. And as a token of our gratitude, I would like to place this. If you can see this, this is the Konark wheel, Professor Dimri, and this small token which will go to you. Yeah. Thank you. This will be sent by post to you, Professor Dimri.
Okay.
Symbolic presentation and the Konark being the symbol. Yes. Thank you.
So nice of you. Thank you.
Thank you. So back to you, Sujit.
Thank you so much, sir. Thank you so much. Now, without wasting any time, I will invite our General Secretary, Mr. Mahanta, to offer formal vote of thanks. Mr. Mahanta, please.
I think you are muted, Tilochan Babu, Mr. Mahanta. Mr. Mahanta is muted.
Mahanta,
No, I think he has problems in opening.
Yes. So, thank you, Sujit. On behalf of the Society of Geoscientists and Allied Technologies, and on my own behalf, I consider myself privileged enough to offer the vote of thanks to an eminent scientist of our country, Padma Shri Dr. Dimri, President Federation of Indian Geosciences Association, expert member, governing body, Govind Vallabh Pant National Institute of Himalayan Environment and Autonomous Institute of Ministry of Environment, Forest and Climate Change, Honorary Scientist of Indian National Science Academy, and former Director CSIR NGRI, Hyderabad, who readily agreed to the request of our Vice President, Sujit Kumar Mahanti, to be amongst us this evening. And this he did with a very short notice. And the topic that he chose, global warming and carbon dioxide sequestration in suitable geological formation in India, it is extremely informative, as already narrated by our president also, and it gives an in-depth knowledge of the scientific efforts undertaken by him and the scientists of CSIR NGR. The knowledge that has been gathered through these scientific works is immense and would definitely pave the way for more research work in this area. Despite his busy schedule on various assignments, Dr. Dimri could find time to make this evening memorable for all of us. Our sincere thanks are to Dr. Dimri for accepting our invitation for the talk. I, on behalf of the society, sincerely thank all the distinguished participants from country and abroad, and they are from different organizations, who made it a point to find time to attend this important lecture by Dr. V.P. Dimri, and without whose participation, this event wouldn't have been successful. Our President, Professor Onkar Nath Mohanty, who is always very keen about the distinguished lecture series of SGAT, not only talked with Dr. Dimri before the talk, but also monitored the minute details of the occasion on day-to-day basis. The society is extremely thankful to you, sir, for your timely guidance and welcoming the distinguished speaker of this occasion, and also giving the concluding remarks. My thanks are also due to Sri Sujit Kumar Mohanty for anchoring the event, Dr. Rajgopal Mohanty for introducing the speaker, and Dr. B.M. Farooq for moderating the question answer session. Last but not the least, other members of the society like Sri Alok Bihari Panigrahi, Vice President, both the Joint Secretaries, Sri Jivan Kumar Mahapatra, Sri Jivan Joy Kumar Hota, and our Treasurer, Sri Anup Kumar Rao, and the entire DLS team helped a lot to make this occasion a reality. My sincere thanks to all of them. Thank you all, sir.
Before we actually conclude this, permit me to say one sentence, and that is, as has become customary, whoever delivers actually this talk, we also invite him to become an honorary member of SGAT. So Professor Dimri, you are going to receive a letter of invitation officially from our SGAT secretary, and we'll be very glad if you actually oblige us with your consent.
My
Professor
honor.
Dimri. Thank you.
It's an honor to be a part of this great society.
Thank you.
So nice.
Thank you all, sir. This session
Thank
is
you.
over now.
We'll be in touch.
Good night. Good
Thank you. We'll be
night.
in touch, sir. Definitely.
Whenever you
And
come to
this-
Hyderabad, please see us.
Yes.
Whenever
And
you
the
come.
75th year of the freedom movement,
Yeah.
and the Independence Day is coming in another 3 days. So all our greetings for wonderful Independence Day. Thank you and good night to all of.
Thank you, sir. Good night. Good night.